All right, so we're going to look at strategy number 2, which is using reduced row echelon form of an augmented matrix. So first off, I think we need to figure out what a matrix is. So a matrix is a rectangular array of size m by n. Okay, and m is equal to the number of rows. So rows going this way, okay? And n is the number of columns, so this way. Okay? A matrix looks something like this. It has these brackets, and I'm going to do, let's see, 1, 2, 3, 4, 5, 6. This would be row 1, row 2, and column 1, column 2, column 3. Okay, so and then we name these matrices like H. Okay, so matrix H is equal to, let's say this. Matrix H is a row by column, so 2 rows by 3 columns. Rows, columns. Okay. So what would a 3 by 4 matrix look like? A 3 by 4 matrix would look something like, well, you make one. Okay, now I'll make one. Okay. So 3 rows by 4 columns. Okay, so 1, 2, 3, 4, 6, 7, 9, 10, 11, 12. So I have row 1, row 2, row 3, column 1, column 2, column 3, column 4. All of the stuff that is highlighted, we don't normally write. I'm just doing it for your reference. Okay. So in the above, so where would entry A sub 21 be? And this is not entry 21. So what this means is this is your M value and your N value. So we're saying row 2, column 1. Okay. So if I'm looking, I'm like, okay, row 2, that would be here. Column 1, that's here. So the entry A21 is equal to 2. Okay. So each number in your matrix is called an entry. So this 3 by 4 would be, let's name this, matrix G. Okay, so this would be, the first entry is G sub 1, 1. So row, column. The second entry would be 2 sub 1. Excuse me, sorry, wrong. Row 1, column 2. Row 1, column 3, G sub 1, comma 4. G sub 2, all of these are row 2. Okay, and this is column 1, column 2, column 3, column 4. Okay, G sub 3 for the row. G sub 3, 1, 3, 2, 3, 3, 3, 4. Okay. So each is a different entry. What is the order of each of these matrix? Order is another word for dimension. Okay, so for A, we would call this a 1 by 1. Again, a row, column. For B, how many rows are there versus the columns? There's 1 row, 4 columns. Okay, so 1 by 4. The last matrix A, row, column. There's 3 rows by 2 columns. Okay, let's go ahead and create a square matrix. So a square matrix is the same, equal rows and columns. So for example, this could be like a 1 by 1, a 2 by 2, a 3 by 3, a 4 by 4, so on and so forth. Okay, so a square matrix, an example of a 2 by 2 would be like 1, 2, 3, 4. That is a square matrix. All right, so there are different types of matrices. So it's plural for matrix is a matrice. Okay, so what we can do is take our system of, what we're going to do is take our system of equations and like deconstruct it into its coefficients, basically. So one type of matrix is the coefficient matrix. So what we do is we take this part, 2x plus 2y, 3x minus 3y, and we go ahead and write only the coefficients in front of the x's and the y's. So that would look like 2, 2, 3, negative 3. Okay. An augmented matrix includes the constants. And really it's 2 matrices in one. Okay. So we're going to do 2, 2, 3, negative 3, put a line, and then the constants go on the other side, 0 and 1. So the line represents the other side of the equation. Okay. So what we're going to do is we're going to look at some row operations. We only have 3 rules. So think about the rules that you can use for solving a system of equations. I can interchange the 2 equations. So like I could write this as 3x minus 3y is equal to 1 and 2x plus 2y is equal to 0. So I can switch the 2 rows. So I'm going to start with my augmented matrix. So 2, 2, 3, negative 3. My constants are 0 and 1. And we use this notation. I'm going to switch row 1 and row 2, interchange them. So now I'm going to write 3, negative 3, 1, and then 2, 2, 0. All right, so that's one operation. Our next operation is to multiply a row by a constant. So think if I'm going to, maybe I want to multiply this top row by 2. I know that doesn't really help us, but that's okay. It's for practice. So I'm going to start with my original matrix. Okay. And what I do, since I'm applying this to row 2, I'm going to go ahead and write it up here. So I'm going to multiply row 1 by 2. And what we get is row 1 by row 2. Sorry, multiply row 1 by 2, a scalar, a constant. Okay, so each one of these numbers is being multiplied by 2, and I'm going to replace that into row 1. Okay, so 2 times 2 is 4, and then 4, and then 0, because 0 times 2, and then row 3 doesn't change. Or row 2 doesn't change. Negative 3, negative 3, negative 3, 1. Okay. Lastly, we're going to multiply a row by a constant or a scalar and add it to another row. Then you're going to replace that second row with the coefficient. So actually, I think I'm going to write this a little different. So same with augmented matrix we were working with before. We're going to see later that it's really helpful if we get a 0 in this place right here. So what I'm going to do is I'm multiplying row 1 by -3/2, and then I'm going to add it to row 2, and that gets replaced into row 2. Okay? Okay. So here we go. I know that row 1 is going to stay the same. So I'm going to do 2, 2, 0. And the only thing that's going to change are these 3 entries down here. So I need to do a little bit of work here. So I need to multiply row 1. So I'm just going to do this on the side. 2 times -3/2. That would cancel, giving me -3. Okay, so -3. And then I'm going to take this number here, 2 times -3/2, which again is -3. Okay, and then 0 times -3/2 is 0. So I'm going to be adding 0. So 3 minus 3 is 0. -3 minus 3 is -6. And 1 plus 0 is 1. Those are our 3 rules that we're going to practice in class tomorrow.